Hey there, Algebra. We're going to review Lesson 11.1 today. Thought it went pretty well from the couple I saw before making this video, but just want to make sure, because this is a real foundational lesson for what we'll be doing this chapter, that we've really got this down and feel comfortable with it. Just a quick review of the two different types of variations we talked about. We talked about inverse variations yesterday when you did your lesson. So just a quick review of what those are, right? Inverse variations are when you can take pairs of x's and y's and multiply them together and always end up with the same thing, right? And they can be written this way, or the way that we worked with more often, this way. X times y equals k, right? Is that answer that they always multiply up to get, okay? And then these we've worked with in past years and earlier this year, right? Direct variations are where you're taking something and doing it to your x to always get your y, right? So like in this situation, we're taking our x times 3 to get our y, and so it can be written like this. Y equals 3 times the x, right? So direct variations can be written that way. So the easiest way to say whether something's an inverse variation or direct variation is just to say it can be written in this form, or it can be written in that form, and then that's your quick explanation. So today all I'm going to do is just do a couple out of your work with you together. How about the first two? Determine whether these are inverse or direct variations, right? Notice number one. If I take all of these times each other, I get this. And so you can say it's inverse, and then don't forget to explain. You can say, here can be your explanation. They all have a product of 4. Or you can say that you can rewrite them in this form, yx equals k. That would work too. However you want to explain that, but don't forget that explanation part. How about number 3? What would we call this one? Do you see that that's a direct variation? Because we can rearrange it to look like this. This plus 0 is optional. Obviously, you could get rid of that. But notice I can write it. And so your explanation could be it's a direct because it can be written in y equals k times x form, right? Direct variation form. So those are the first couple. Notice on 4, 5, 6, and 7, there's 2 steps. They want you to write an inverse variation equation, okay? Then graph the equation. So remember, to write an inverse variation equation, let's just put it in this form. Let's figure out what k is. So if y is 2, x is 5, right, equals k, that means 10 equals k. So if I put that back into the original equation, I get x times y equals 10. So there's my equation for number 4. So that's step 1. Don't forget that step. And then graph the equation. Okay, so we just need to think of pairs that together equal 10. If it helps you to make an XY chart, I would recommend it. You might be able to think of pairs in your head. Now remember, we're going to have an equation or a graph that mirrors itself. So we need to make sure we have some negative values and some positive values. So what if we did like 1 and 10, 2 and 5, and we can go backwards to 5 and 2, right? And then let's get some negative pairs in there too. So like -1 and -10, right? -2 and -5, and -5 and -2, and so on. So if we graph those, 1, 10 would be about right here, right? 2, 5, now we're going up by 2s, so it would be about right there, right? And then 5, 2 would be about right here. So notice we're getting our curve, right? It's looking kind of like that. So we should have a mirrored curve on the opposite side. -1, -10, obviously it'd be about right here. -2, -5 would be about right there. And then -5, -2 would be about right here. And so notice we're ending up with that opposite curve then on this other side. Put our arrows on it. We should have a mirror. You should always see a mirror between these two if you go across the origin, 0, 0. So don't forget your 2 steps for those. You need both an equation, right? Don't forget that. Simple equation to write, and then your graph, part 1, part 2. If you don't need to make an XY table, that's up to you, but that doesn't have to be part of your answer, but that can sometimes help you organize. Make sure you're using enough positive numbers and enough negative numbers to give you an idea of where those curves curve. And we'll do a couple of the bottom ones too. Notice it says solve, assume that y varies inversely as x. In other words, we've got a pair of inverse numbers here, right? So that they would multiply together to equal same. Remember this equation that we wrote? x1 times y1 equals x2 times y2, right? In other words, the two pairs have to multiply together to equal the same amount if they're going to be an inverse equation, right? And so if y equals 4 when x equals 8, that's our first pair, right? So I can put them right here. And then find y when x equals 2. So notice 4 times 8 gives us 32, and we have 2 times y. So to solve for y, we just divide by 2. So we get 16 equals y. And so there's our number 8's first problem. How about one more? Let's do, how about 13? Okay, so we've got our first pair, right? It says if y equals 48 when x equals negative 4, that equals find y when x equals 6. Okay, 48 times negative 4 is negative 192 equals 6 times y, right? So if I divide both sides by 6, cancels that out, and we'll find our other y. 192 divided by 6 is negative 32. So there's our y for number 13. So that's how you can solve numbers 8 through 14. I think those will go pretty quickly for you. All right, if you have any other questions beyond those, don't be afraid to reach out. But again, I thought yesterday went really, really well for you guys, at least the ones I was able to see before I had to make this video. I'm assuming the others will go well too, but don't be afraid to reach out if you get stuck, and then we'll head on to lesson 2 tomorrow. Have a good day, everybody.